my name is Erwin Lubbers and I'm the data architect at GILO Technologies. My focus here is on data science, or more particularly natural language processing, NLP. And although I can talk about hours for this, I will narrow it down to the one thing I love to talk about most, which is logic errors. Basically, when your claims are not supported by the facts. Now, logic errors, they come in many shapes and forms. I believe we identified 72 different ones. But I think many of them can be solved with the knowledge graph. Knowledge graph is a technique that Google pioneered a few years ago in their quest to understand, to map all the knowledge on the internet, to index it, to search it. Well, whether they succeeded or not, I'm gonna leave up to your judgment. Here we can see an example of a small knowledge graph. The colorful boxes, they're called nodes. Knowledge graphs store entities such as objects and people and concepts in there. It can either be an instance of something or the actual theory of something. Like you can say, what is an academic paper, or a specific paper, like the theory of the firm by Professor Jensen is an academic paper. Be it as it may, there are connections between these nodes called edges. And edges, it's usually a bit like a verb. It connects two nodes and it clarifies the relationship, as in the person Erwin Lubbers works at the company GILO, or the person Erwin Lubbers lives in the country, the Netherlands. Now we can develop paths that go from one node to the other to find more complex stories. For example, does the person Erwin Lubbers, is that an AI expert? So we find Erwin, we find the connection works at GILO, and then we find the connection GILO is expertise of deep learning. Well, that does not fully clarify whether Erwin Lubbers is a deep learning expert, because he might do very different things at GILO. Therefore, we need to develop reinforcement learning, which is a technique originating from robotics. And it allows for an agent to, well, autonomously discover things and goal things through a reward system, which makes that perfectly suitable for the knowledge graph. So an agent can discover whether Erwin Lubbers works at GILO and whether it's an expert in deep learning, and it must make its own judgments by that based on deep learning. So how do we make this knowledge graph? Well, it takes a lot of steps and a lot of knowledge actually to pull this off. But luckily for the last year, I've been working on all the different components that build this knowledge graph for, well, their own functions at the GILO app. First of all, we got semantic search, which is basically more like how a user naturally interacts with something like Siri. You ask Siri, Siri, give me all the pizza places in my area. You don't type in Pizza Hut Rijswijk. Gone these days for simple search. Well, where we search on, first of all, we need a taxonomy. And at GILO, I have my taxonomy of business terms. We got about 17,000 unique terms, which can be the basis of our nodes. Then we have a large text corpus. In this case, I have about 100 textbooks and 1,300 research articles. Why is this important? Usually Google, for example, they just scrape the web, but you get a lot of garbage. There's a lot of garbage out there on the web. And what I need is specific business and academic papers to, well, more narrow it down to our little fields. After that, we need named entity recognition, aka keyword extractions. We need to know what are the words in there. We need to classify these terms once we got them. And then we get to text mining, which is basically we must understand what the text is about. What is the context of the text? What are the people mentioned? What are the different variables? What is everything in this text? Then finally, we get to a deep learning model that must go through the text and extract sort of the relationships. And it also must decide whether it is worthwhile storing or not. For example, you can find a sentence, Professor Fama and French wrote the three-factor tier model to predict stock prices, which says Fama and French are co-authors. Fama and French are both professors, and Fama and French wrote the three-factor model. In another sentence, you may find Fama went with his good buddy French to the Burger King. They both ate a Whopper and had a vanilla milkshake. Now, it contains, usually a computer doesn't really know it's, oh yeah, the objects, the Fama and French, they went to the Burger King, they ate him a Whopper, but that's not storage knowledge. That's not knowledge you want to store. So your AI need to be well trained to understand what is worth keeping and what is worth throwing away. And that will be probably the most challenging aspect of this idea. Anyway, if we all put it together, we can make reinforcement learning discover things. It can go through this path and it can see if knowledge is there or not. And maybe it discovers things we didn't know yet. Who knows? But let's not get ahead of ourselves. I'm going to end with a simple example, like what I'm trying to do here. We're trying to help the students write their academic papers. We're trying to help business people, well, try to create better papers. So for example, a user can write, companies are financed by equity sales, which, well, first sounds plausible, but when you look it up, you look up company, you can, it's an entity, then you see the edges, the relationships. You look at financed by equity, but also financed by debt. You can see maybe the research paper, the cost of capital by, who was that, Miller and Mogliani or something. Be it as it may, companies are financed by equity sales. Well, it's partially true, but not really. It's equity investment and debt investments. And well, just like that, you can probably come up with a million examples that could be possible with this technique. Okay, well, I'm gonna stop at it now, otherwise I'll take up too much time, and I'm gonna give back the words to my dear colleagues. Well, thank you for your time.